Hi, everyone. This is the day 3 walkthrough video for externalities and public goods. I'm going to give you a little bit of background and ideas about each of these slides, kind of tell you what we were thinking and let you know how you can use them in your classroom. So to get us started, our bell ringer for day 3 compares this neighborhood dispute with redwoods and solar panels. You can read the scenario there. The idea that we want students thinking about here is how can you solve this externalities problem, right? Can you identify what the externality is? Can you find a solution? And since students on days 1 and 2 have learned Pigouvian taxes and subsidies, they might try and apply that here, but they're going to learn that that's not going to be a solution that's easily workable in this case, right? So this is introducing them to the idea that we need more and possibly different kinds of solutions for externalities problems. So classroom discussion, you can have students discuss in a small group, maybe with a partner, or in a larger group, even as a full class, depending on what works in your situation. And if you need ideas on what some possible solutions are, we've kind of outlined a couple, right? So Mark could pay for his neighbors to remove the tree. He could pay to relocate the trees, right? Maybe you can plant them somewhere else. Richard and Carolyn could pay Mark to move the solar panels, right? So they could compensate him by moving those panels, or maybe they could offer to pay for some of the loss of power because of the shade from the trees. And what this is leading us to is Coase's solution to externalities. So introducing this idea of defining property rights and allowing parties to negotiate a solution. And as with all different approaches to externalities, right, we have some situations where it works and where it doesn't. So in this case, we need low transaction costs, right? Is it low cost? Is it easy to organize? Can you work together in a group? Can you identify people who you need to talk to, right? Are those transaction costs of making a deal low? And do we have some clearly defined property rights, right? Can we make it clear who owns, in this case, the shade or the sunlight? And California did, in fact, this was a real situation. So this scenario from the bell ringer did happen. And California solve this problem, right? They defined a right to sunlight in the Solar Shade Control Act of 1978. And so the California judge ordered the trees cut down. Now, there was a lot of public outcry. Everybody loved these beloved redwood trees. And so they actually redefined the law and updated it to exempt trees planted prior to the solar panel installation. So if you plant the trees first, the trees get to stay. The solar panels are first, the solar panel stays, right? So this based on whoever's there first. And then that leads into our video of trading pollution. So in this video, you should check it out, go watch it. We compare 2 different solutions to solving pollution problems, right? So one is a command and control approach, right? So we want students to be introduced to command and control approaches. What are they? We give a couple of examples, right? So you can set a maximum level of pollution at every factory, or you can install or require a specific technology to be installed at each factory. Each of our questions gives you a time that you can pause the video and ask them, right? So they match up with the times in the video. And then we're trying to get students to pay attention. Where do we want to reduce pollution more? Like, why does it matter here? Well, we want it to be where it's a lower cost to reduce pollution, right? And so we'll talk a little bit more about that, right? So another approach, right? So we can have a command and control solution. We can say, okay, every factory has to reduce pollution by the same amount, or we can issue pollution permits, right? This is going to be our comparison for the video. And so, right, we want to compare 2 things. One is how much pollution are we reducing, and how does the cost compare for the 2, right? So these are the 2 metrics which are analyzed in the video. And the total pollution reduction is the same based on how many permits you sell, but the cost is much lower. And that's what we want students to recognize, is that the cost is different for different approaches of resolving externalities problems. And this leads us back to an insight from the law of demand, right? So it's a relatively simple idea, right? The law of demand is that when the price goes down, the quantity demanded increases, and that applies here to pollution reduction, right? So when the price of pollution reduction decreases, the quantity demanded will increase. We'll actually want to reduce more pollution, which I think is great insight, and just very clearly explained with the supply and demand graph. So after the video, we asked students to explain in their own words why the total cost is different. We want students to internalize that, be able to explain that. You can ask them to explain it to a neighbor, right? A turn and talk situation. We'd also want them to write it down somewhere. So maybe they turn and talk, discuss it, and then write down a summary if you have time in your class for that. We give you here a couple different points that you can emphasize in explaining that if your students need a little bit of help. These can be a guide to you. And then we summarize, right, these three approaches to resolving externalities problems. We have the Pigouvian approach, command and control, property rights, and tradable permits. We've grouped that into, right, one grouping for simplicity's sake. Here we have just a little bit of description, a brief review. And then we ask students on the next slide, this is in their student activity sheet, they get a table like this. If they're taking notes in a Chromebook, right, they can expand the table as they need for their notes. You might want to make it bigger if you're printing it off to make sure students just have plenty of space for notes here, because they're going to have a lot that they might want to put in this table. First off, we ask students to really think about the advantages and disadvantages on their own, right? Can they think about, oh, where is this solution going to work well? Why would you want to do the solution, right? What are the advantages? And then maybe what are some disadvantages? What are some difficulties in using this approach to resolve an externalities problem, right? That's going to look different in different circumstances, but we kind of want to get them thinking critically about, oh, when does this work well? When is it going to have some trouble? And then we give you a guide, right? So we have a slide for each of the different approaches, right? So some of the benefits of Pigouvian are, right, you can eliminate that dead weight loss. And it does allow a price comparison with the tax, right? So you can choose to pay the tax or you can switch to something else. But it can be hard to find that optimal amount. There can be some difficulty in imposing a Pigouvian tax if it's not politically feasible. So as an example, we link to an article about New York repealing congestion pricing. So they were going to tax entering New York City below 60th Street, so that concentrated dense area of Manhattan. And the governor pulled the legislation just before it was about to go in. It was politically unpopular, right? And so that can be a difficulty in implementing a Pigouvian approach. And right, on all of these, we can have some unintended consequences, and we'll get to an example of that in a little bit. So with a command and control approach, right, the advantage is it's really straightforward. You can guarantee a certain amount and you can talk about it. It's really easy to explain in a public speech, but it can be really difficult to pick what is that best optimal solution. Is that going to work for every factory? Is that going to work for every situation? Again, there might be unintended consequences. And you're going to have some incentive to evade enforcement, right? So then we give the example of Volkswagen trying to evade emission standards, right? And so they had developed a way to evade those standards, right? So you can look that up. And then we summarize, right, the advantages and disadvantages of, say, property rights and tradable permit solution approach, right? So you can get that negotiation. It can be really efficient. You get that price signal, signaling to parties what they should do. But again, you have some difficulty, right? So it can be difficult to define that property right, difficult to organize if you have a large group. If you have a large group where the costs are low per person, it can be really hard to motivate people to organize. Might not be rational for them to spend their time doing so. And then you have a initial property right allocation question. How do you decide who gets the right to start with? Because it'll matter on who financially benefits. And then to really illustrate the idea that it's not so easy to solve these externalities problems, that you do have unintended consequences, even when you've identified an externality. We've created this choose your own interactive style thing. Oh, we got to start back at the beginning. Okay, so The idea here is you kind of get to explore policies and see maybe where there are some unintended consequences. It's not quite as easy as you might imagine. And so we want students to really think about, okay, we're going to reduce some pollution, right? So classic negative externality problem. And you can pick, right? So do you want to talk about appliances or cars? We're going to look at cars for right now, right? Students get to pick. Okay, so we're concerned about CO2. Then we're going to think about, do we want to subsidize cars or set stricter fuel efficiency standards? Let's say we want to check out subsidies. Great. So we got people to add alternative fuel tanks. Seems like things are going well. But actually, they put these tanks on cars and nobody's using them, right? So we thought that this would get people to use maybe alternative fuel sources, but they aren't using those alternative fuel tanks and it actually costs a lot, right? And then we've got a link to an similar policy, right? So there's a lot of different options. It keeps going, right? And the idea here is just to get students to see, right, we can try and solve an externalities problem, but sometimes in some of these cases, we've created a worse problem or we spend a bunch of money and we don't get a result. So just thinking about, right, solving externalities isn't as simple as slapping a Pigouvian tax or subsidy on something and moving on with our day. There's a lot more to it. Then we ask students, right, to come up with their own solution to this kind of comical problem, but it's a real problem where a dog food factory is making life miserable for nearby residents because of the smell that's emitting from the factory, right? So we want them to think, right, identify the externality problem. We want them to think about 3 different solutions, right? A Pigouvian solution, a command and control solution, and a tradable property rights solution, and then pick which one is the best. So we really want them to use those critical thinking skills, kind of evaluate amongst the options, kind of maybe argue with one another, working in small groups like, oh, is this better? Is this better? And really think about what goes into solving an externalities problem. And then at the end, we have an exit ticket, right? So naming those 3 approaches. And then this is an example of using metacognition in our lessons. So how confident are you explaining each approach, right? Rate your confidence. This can be a guide for students to decide what they should study next, what they should be thinking about, where they need to go back and spend more focus. So that's day 3. If you haven't already, you can request our unit plan on externalities and public goods, and there should be a link to take you there, or you can move to the next video and watch about day 4.